Hello and welcome to 10 Minutes to a Better Building, a podcast brought to you by Boland. I'm your host, Michelle Dawn Mooney, and today we're talking about how to improve the air quality of your building. And I have a great guest to bring on for that conversation. Josh Howell is the Commercial Territory Manager for Dynamic Air Quality Solutions. Josh, thank you so much for being with me today.
Hey, thank you for having me. We're very, very excited for this opportunity.
Yeah, it's going to be a great conversation. So before we jump into that, can you give people a little bit of a background so they know who they're about to hear from?
Yeah, so my name is Josh Howell. I'm the Commercial Territory Manager for Dynamic Air Quality Solutions. And I've been with Dynamic Air about 6 years. I'm a certified air filtration specialist. And our company, just real short, been around since 1982, engineering filtration solutions for buildings.
Perfect. So let's start off with the star of the show, so to speak, is air quality. Let's talk about what is all entailed with air quality. When we think of air quality, how it's measured, and then basically how vital is it to ensure that we have the best quality of air out there?
Okay, so when you say what IAQ entails, that's a big category for us. It goes from data that shows that IAQ relates to the productivity of employees, right? They are more active. There's less VOCs and types of contaminants that recirculate in the space. So it's better for productivity. When you take that further, if you're a healthcare facility or a K through 12 school, let's say, you now care about the people in your buildings. Everyone should care about the people in their buildings, but even more so if you've got people that have an illness or they're having surgeries or whatever it is, and you want to control all the contaminants to that space. The second thing is building code. By code, some buildings are required to have a level of IAQ, specifically hospitals. Things like the NICU, things like burn units have to have what's called a HEPA filter, which is kind of industry regarded as, the cat's meow or the highest filtration you can get. So there's building code, there's IAQ for the employees. There's also the IAQ side that's the energy and maintenance. There's a cost of providing that good IAQ, and how do you balance that as a building owner or as anyone, an engineer designing a building? It's, do I go to this level of IAQ and have this energy and maintenance penalty, or do I meet somewhere in the middle? And that's the struggle that we see on a day-to-day with buildings.
Let's talk a little bit more about that struggle, because good air quality doesn't just happen by itself. We need some help along the way. So what are some of the biggest challenges that you hear from facilities who are trying to get the best air quality they can?
The biggest thing is keeping the maintenance up to date. Lack of maintenance personnel is a thing we've heard a lot during COVID. I don't have as many guys to change filters. And what happens with a filter is being that the standard filtration that is used in commercial buildings is a passive filter, or for lack of a better word, paper or fibers with holes in it, right? It doesn't have a lot of technology in there. You need to change those when they're supposed to be changed. If that needs to be changed in 6 months and we leave that filter in for 2 years, well, there's huge penalties on that. And sometimes they just can't get to it. It's not a bucket list item for them when they've got equipment broken over here, right, to go change filters. So we see that a lot, is that filters aren't operated the way they're supposed to be. That's probably the biggest challenge. UVC lights are being used everywhere right now to kill viruses and pathogens. But a UV light loses 5 to 8% intensity every year. So in 3-4 years, if you hadn't changed that bulb, you might not be doing anything now. And that's the biggest challenge we see, is that there's a lot of good products, but if they're not applied correctly, not taken care of, that kind of stuff, then it doesn't work like it's supposed to work. The last thing I'll say is install is standard filters. They're put in this rack, right? And they may have cracks in between them. Well, what we know about airflow is that if there's a crack, a vast majority of that air goes through the crack because it doesn't have to go through a filter. It's all about the resistance and the path of least resistance. So you may have a high quality filter in there, but if it doesn't get installed properly, it doesn't work. So there's a lot of challenges from the owner side that you don't see with, on the testing and the sales side of most filters, is that there's a whole nother story to that when it actually gets in the building.
Let's talk about the good news solutions, because there are some solutions out there. So what are you seeing in the way of products that are really helping these facilities get the best air quality they can and making it a little bit easier and cost effective as well?
Yeah, right. So we see the struggle all the time is man, I just don't have people to change filters, or buying all these filters every 3 months and having to store them in storage rooms. Because let's take university, for instance, we have some products there, and that whole campus, I mean, they have thousands and thousands of paper filters that they have to keep track of and change. And it just is a huge burden. And what they don't see a lot of times is the energy burden. And why they don't see the energy side is because there's not a lot out there on the market that provides savings, right? It's kind of all standard. This is a MERV 13 filter or a MERV 11 filter or whatever level filter it is. And they're kind of all about the same. What we offer specifically at Dynamic with our products is we tried to basically solve all those issues. So we use a combination of a passive filter with electronic mechanisms as well to essentially enhance that passive filter to hold more dust, which means it lasts a lot longer. And also the electronics increase the efficiency on really small stuff. VOCs, gas phase type stuff, really, really small stuff that no other filters can get. So from a pain of ownership, if you will, perspective, our stuff's built to last years with no maintenance. You put it in and you don't touch it. Smithsonian African American Museum has our V8 product, and they went 6 years without $1 and 1 minute spent on changing filters. Vice 5, 6, 7 change outs a year for some facilities. I mean, the savings there and just the burden we've taken off the owner. That's what I see from a feedback loop that just you really can't even put a price on.
Yeah, I was going to ask you a little bit more about that because clearly you're giving some examples of what it's doing for these facilities and organizations, but any specific examples of that feedback of just how well it is working for some of these institutions?
Sure. I mean, let's dive a little bit into a standard. Let's say a museum, right, or a higher ed. They would typically have, let's say, by code or what we standardly see in the market, the same filtration. And what that typically is it's MERV 13 level. That's what's used for LEED buildings, well buildings, any kind of high performance museum, higher ed. MERV 13 is kind of the cutoff from a IAQ level that they want to see. Well, typically MERV 13 filters require a pre-filter. And why they do that is because a MERV 13 is built to catch small stuff. Well, if I load that with really big stuff, right, pollen and really big stuff, I hurt the life of that filter. So we add a pre-filter to get the big stuff, MERV 13 to get the small stuff. So that's a typical museum kind of like filtration setup. And from an energy perspective and a maintenance perspective, that would typically be both of those combined. We use static pressure as basically our energy metric because that's a resistance metric, right, of how hard it is to push through a filter. And that typical setup would be 1.5 to 2 inches of static pressure probably when they're loaded, okay? And there'd be 5 change outs a year, right? So let's think about that. So we're changing filters every 3 months, and we're running to 1.5 or 2 inches of static from an energy side. And we've got MERV 13 level. You enter a product like the V8, which they have now, and we have MERV 15 filtration, which is 20, 30, 40 percentage points better on the really small stuff than what they have now. So far superior air quality. It's going to last 5 years instead of having to change out 3 months. No, you don't have to touch it for 5 years. And the energy is 1/3 of that energy. So all three of those sides, and what that ends up coming out to, if some big picture numbers, is it's about 6% of the total building utility bill saved just by using a dynamic product versus standard filters. You branch that to the whole grid of the U.S., commercial buildings consume 40% of all the energy in the U.S. 40% of the whole grid is commercial buildings. And when you break that down, the filter is about 8% of the total building energy footprint of the USA. And I can cut down 75% of that. I mean, when you talk about decarbonization and the way the world's going, like being able to save those kilowatts, we have to do that because we can't make as much, right? With solar and wind energy, the more we can save, the less we have to make. All contributes to the sustainability goal of the world.
So Josh, it sounds great. Obviously, you're giving examples of institutions and facilities that are seeing the results, but how do you do that? Like, how does that work? It almost
Right.
sounds too good to be true, I think, for some people.
Yeah, and we get that a lot, and it's I go back to it's really a disruptive type technology product, and it's different. It's what we've done is we've leveraged a bunch of different proven technologies. We used polarized media technology, and as I said, it's a passive media that we enhance with electronics that we actually charge the media, and what we get is what we call 360-degree loading. So if you think about a fiber or a hair, however you want to think about it, a spun fiber that could hold particles, every passive filter can only hold on the front on 180 degrees of that because they just basically stop what doesn't go through. Because we have electronic mechanism of attraction, we can hold on the fronts, the backs, the sides, all around those fibers. So that's why we can hold so much more. That's why we can last longer than anything out there on the market because of those leveraged technologies. You put that also together with we have a zero bypass system. I talked about the cracks, like the way ours is designed, which is, as again, very different than regular filters. It's modular. It's like Legos. You put it in an air handler, you seal it, so there's no way any air can blow by. So I'm going to get my tested lab performance in your building, which cannot be said from standard filters. They're not installed properly. So all these things kind of trundle into one product, and we'll get to kind of some of the cons, but it's bigger than normal filters for a reason. And it was built to pay back versus a standard filter in less than 5 years. That was the goal of the engineering process. So that's all that put together to get to that goal.
You mentioned cons, so we have to bring it up. I mean, clearly no product or system is perfect, and this is not a one size fits all model that we're talking about here. So what are the cons, and how does that relate to maybe potential institution facility managers out there that, they might be kind of on the fence of, is this even a product that they can use?
Right. So the number one con we get is size. And as I said, think about you have a limited space, right? In your air handling unit where you have your fans and your coils, you have a limited space. The standard filters will be 12 to 14 inches deep, as we talked about in the example, but our stuff is at least 24 inches. We have a 24 and a 30. And so a lot of times that's not fittable into an existing air handler, and that's a challenge. But it has to be that big to provide the benefits and to be able to provide the savings that it does. And that was the goal. So as I said, there's always a give and take with filtration. Our only downside is first cost, which we'll talk about next, and size. Everything else you get a benefit on. And in our mind, that's the right way to do filtration.
Let's talk about the cost, because we can't talk about a great product and it's doing all these amazing things without asking, well, how much is it going to cost? So how much is it going to cost?
Okay. So going to the different model, right? Standard filters are what we call P&L item, what most employees would call P&L item, right? It's a budget yearly kind of deal. Whereas our stuff, being that it's designed to last 5, 6, 7 years at a time with no additional cost, it's a capital item. It's a different bucket of money for customers. And sometimes that's a struggle. As far as how much does it cost? The initial cost is what's so big of a deal, because I'm buying metal, I'm buying electronics, I'm buying all the gear that goes with that. And that may be 5 to 8 times the cost of your normal filters. But over the course of 10, 15 years, when we run our financial analysis, it's a 40 to 50% savings with dynamic versus what you have now. So any building that you're building, think about the examples, museums, higher ed, they're building buildings for 30, 40 years. And our system over that course of time is over 50% savings, including that first cost. So yes, it's a challenge, but in the end, I would say that we're the lowest price filter possible.
So as we're wrapping up here, because I know a lot of people are going to have some questions about this, you talked about financial analysis. What is that? Are there ways to maybe make this cost effective? And where can people get more information if they're really thinking, I think this might be a good choice for us, but we're not sure? The
best thing I can say is let us run the numbers. I mean, we do free financial analysis, and let us show you your numbers for your specific building. You give us the info on how you run your building, and we'll tell you what the savings are. And if they're not good enough, they're not good enough. But most of the time, what I see is it's pretty eye-opening to the customer. And then we just have to find a way to justify that first cost, which I think in the next episode, we're going to go pretty in depth into how we pay for the capital, how the money comes out, and how we kind of justify the savings in our analysis.
You gave away my teaser, Josh, because we're going to talk about much more in depth of just how much money you can save and some ways to cut things down with the actual bill too, things that you may not even realize that are out there. So Josh Howell is the commercial territory manager for Dynamic Air Quality Solutions. And Josh, if people are having questions, they want to find out more information, what's the best way for them to get in contact?
So in the DC market, we are partnered with Bowl and Train. You can reach out to us on our website or our headquarters link if you have general questions to me. But as far as getting orders done, getting financial analysis done, the best route is to go through whoever your Bowl and Train representative is in the DC market.
Josh, thank you so much for your time. Looking forward to part 2 to learn how we can save even more money and how this is really going to be a cost-effective solution for the long term. So thank you for being with me today.
Thank you so much for having me.
And thank you for listening and tuning in to 10 Minutes to a Better Building. We were talking about how to improve the air quality of your building. And for our next episode, don't want to miss that. We're going to tell you deep dive of how much you can save and ways that you can save on the initial cost. So you don't want to miss that. I'm your host, Michelle Dawn Mooney. Thanks again for joining us. We hope to see you again soon.